to my math YouTube channel. In this video, I want to talk about the roots of a complex number. Guys, so far we have already covered topics like how to multiply two complex numbers in the polar form, how to divide two complex numbers in the polar form, and how to take the powers of a complex number. Now we want to see how to find the roots of a complex number. So guys, in this section, I'm going to start with a very classical and a very popular example in this section, which is called finding the cube root of unity. And from that particular example, we will understand how to actually find roots for any complex number. So let us start talking about how to find the cube root of unity. So cube root of unity. So which is same as saying 1 to the power 1/3, so you can put it like this, cube root of 1. Or sometimes guys, people like to think of this as solving an equation of the form x cubed minus 1 equal to 0. Why? Because if you think about this equation and if you try to start solving this, obviously you will add 1 to both sides. First you get x cubed equals to 1, and to get x by itself one has to raise it to the power 1/3. So x would be finally 1 to the power 1/3, so which is same as cube root of 1. So guys, so far from our knowledge of the pre-calculus and algebra, we would just simply say that, hey, cube root of 1, even if we use a calculator for that matter, or we would already, like, just by using the simple common sense stuff, we can say that, or we would say that the value for x is just 1. 1 is the only solution to this equation, or you can say that, or we would say that the cube root of unity or cube root of 1 is just 1. But guys, that is partially correct. That is not the only solution for this particular equation, or that is not the only cube root of unity. And how do we know that? For that, guys, we have to, for that we have to kind of go back and recall the fact that when we are trying to find a cube root, we're expected to get 3 solutions. Here we have only one solution, but we already know from the nice theorems that we have learned in the section where we talked about different solutions of polynomial equations. So we already know that there's going to be 3 solutions. Guys, we already have one of them. What are the other 2? So far from the tools that we have learned and we have understood from algebra and pre-calc, we may not be able to really answer that completely, but now we have learned more stuff in this section on trig functions and relationship between the standard form of a complex number and the trig form, which is we also like to call as the polar form. Now we think we should be able to answer, or we should be able to figure out those other 2 solutions. So guys, how do we figure out, how can we figure out those solutions? In order to do that, one has to go back and one has to kind of look at this unity, look at the 1, and see if we can rewrite this in a polar form. As soon as we start writing it in a polar form, guys, that is going to open up a lot of opportunities for us to kind of analyze that. And then from there, we should be able to figure out all the 3 roots or solutions of cube root of unity, or for that matter, this particular equation. Okay, so how are we going to set this up? First of all, we're going to write, what do we want to figure out? We want to figure out 1 to the power 1/3. Okay, I like this one. This is the most user-friendlier way of expressing this. Guys, it is the same thing as writing this or solving this particular equation. Now, in order to find all the 3 solutions, we know we'll have 3 solutions or 3 values for this. Right, we'll have 3 values. We already know one of them, right? But we have to find the other 2. But the process that we're going to use here is going to give us all 3. So the first thing we're going to do is we're going to try and rewrite this 1 inside the parentheses into a polar form. And we already know that we can write any complex number. For that matter, 1 is also a complex number. It's 1 plus 0i, right? Every number out there is a complex number first, and then you can categorize it as a real or a purely imaginary, then rational, integers, and all that. So first step would be trying to write this in a polar form, and it should not be too difficult. If you have already watched my videos, or if you already have gone through all everything before this particular section in the textbook, guys, then you know how to transform a complex number from a standard form to a polar form. So let us quickly do that. In order to do that, I'm going to rewrite this as 1 plus 0i. Guys, my real part is 1, my imaginary part b is 0. So the first thing that I like to do is I like to plot this. This is my real axis, this is my imaginary axis. I'm sure at this point some of you can do it maybe without plotting. Guys, that is fine, but I always like to go back to the basics and I like to write all the steps. So I'm going to write all the steps. So this complex number 1 plus 0i, which is basically just the number 1, it can be represented on this complex plane right here, because a is 1 and b is 0. So that is my 1 plus 0i, or you can think of that 1 and comma 0 as a coordinate pair. Now I have to write this in a polar form and a trig form. We know the trig form is r times cosine of theta plus I times sine of theta, right? That is our polar form. We know r is the distance of the complex number from the origin. It's the absolute value. And we know the angle theta is the angle that it makes with the reference side, this being always the reference side. Now we can see that this complex number is how far from the origin. We don't have to do any extra work or any extra math to figure out the distance, how far it is from the origin. Guys, we can clearly see that it is only 1 unit away from the origin. So that means r is 1. Okay, I'm going to write it here, but then we don't really have to write it because 1 times any quantity is just this quantity. It's not going to change anything. And then we have to write the cosine of the theta. Guys, obviously this is overlapping with that reference side. That means the angle that it makes, that is going to be just 0 degrees. So it's going to be cosine of 0 plus I sine of 0. That is how we can transform 1 into in a polar form. Guys, cosine 0 we know is 1, sine 0 is 0. So 1 times 1 is 1. We get the same thing. So that's just a verifying step. But guys, keep in mind, this is not the only way of expressing this in a polar form. Of course, this is one of the ways, but guys, there's more ways of expressing this one as a polar form. And keep in mind, this distance is not going to change. It is still going to be 1, but you can go around, you know, cosine and sine, these are periodic functions. They repeat themselves after a certain amount of angle or a certain amount of time. So guys, if we go around, if we think about going around this circle once, and we will reach back here if we go around 360 degrees. Again, if we go around one more time, 360 degrees, we will be covering 720 degrees, but we'll get back to the same thing. So guys, if 1 is equivalent to this, then 1 also will be equivalent to 1 times cosine of 360 plus I times sine of 360. And if that is true, then it is also equivalent to 1 times cosine of 360 plus 360. As long as we can get back onto the same place, like we go back once and we'll end up being in the same place, going around 360 degrees. Guys, we can keep on going around this circle forever. We'll get back to the same position. So it will be 360 plus 360 plus I times sine of 360 plus 360. So then one would say that why stop right here? And why not just keep going through and keep adding these 360s over and over again? Yes, guys, like we can actually do that. We can keep on doing it. But the thing with that is, after we pass the 3 of them, then things are going to repeat. And that is something that you will see once we start actually writing the solutions, and then we can compare it. If we go to the 4th step of going around one more time around the circle, then it is going to overlap with one of those values. And guys, the other reason that you can kind of think about right now is we already know that we are going to get 3 values, or if you think in terms of solving the solution, finding the values of x, finding the solutions, we're going to get 3 solutions. Here we have 3 of them, so we don't have to really go up to the 4th one, okay? But you can also understand this from a conceptual way of like looking at the solutions once we get them, and then you will see that the rest of the solutions are just going to be overlapping with these 3. Okay, so let us go ahead and now start finding our 3 values. Guys, keep in mind, we are not interested only in finding what is 1 in terms of the trig functions or in terms of the polar form. We want to find 1 raised to the power 1/3. Guys, these are 3 equivalent forms of expressing the complex number 1 plus 0i, which in turn is basically expressing 1. Now we have to raise it to the power 1/3. So we're going to raise each one of these to the power 1/3 and see if we get the same values or we get different values. And guys, those 3 values that we get are going to be our values for this particular cube root of unity, or you can think of that as solution of this particular equation. So let us go ahead and do that. The first one, I'm going to raise this to the power 1/3. So that should not be such a problem, because it is just, guys, we can ignore that 1. So let me get rid of that 1. So it's just cosine 0 plus I sine 0 raising to the power 1/3. That's my first solution, or that's my first value. Guys, let us simplify this. Cosine 0, we can look at the unit circle from here. It's 1. So it is 1 plus 0i raised to the power 1/3. And from here, it's 1 to the power 1/3. 1 to the power 1/3 is 1. We already know that. So that is one of the solutions which we already knew, right? There was nothing really interesting about that. But now let us look at the other 2 values, because those are the ones that are going to be interesting to us. So Let us start looking at the second one. Guys, for the second one, we have cosine of 360 plus I times sine of 360. Again, I got to raise this to the power 1/3. So in here, guys, what are we going to do? Well, what we should do first is, and I could have done the same thing here as well. Well, this was very simple, so that's why I did not really use the de Moivre's theorem. But guys, here one should use the de Moivre's theorem. Using the de Moivre's theorem, what happens? This this exponent has to be multiplied with the angle. So 1/3 times 360, same thing, 1/3 times 360. When we do that, we are going to get cosine of, so when we simplify this using the de Moivre's theorem, we're going to get cosine of 360 times 1/3, which is going to be 120. So I'm going to write cosine of 120 degrees plus I times sine of, again, 120 degrees. Okay. So guys, I want to kind of go back because I want to be consistent with using the same method. So guys, let me go back to this step right here. Guys, in this step, I would first actually just want to use the de Moivre's theorem. Using the de Moivre's theorem, 0 times 1/3 is still 0, and it is sine of 0 times 1/3 is still 0. So when I simplify this, I get just a 1. So I think we should use the de Moivre's theorem here as well in the first step. Although we could have done it just without using that as well, because it was very simple. But guys, let us be consistent. We are using de Moivre's theorem for all three of them when we are raising it to the power 1/3. Now from here, cosine 120 plus I sine 120, that is the value when I raise this 1 to the power 1/3. But this and this, guys, we have to look into the unit circle and figure out what are the values for those. And looking at my unit circle, I'm looking at my unit circle, and this is what I have. -1/2 for this, and plus I times radical 3/2. So guys, that was one of my solutions. Now I have another solution, and you should verify that when you raise this to the power 3, what you're going to get is just a 1. Just by looking at it, you may not think that is going to be the answer, but guys, try multiplying it 3 times. You should get 1, and that's something that you should verify on your own. Now we still have to find the third, because we know we're going to get 3 values, right? And that's why it's called cube root of unity. We will get 3 values. Now guys, again, there's one other thing that you should keep in mind. Whenever we have complex solutions, we should know that complex solutions always occur in pairs. And in pairs, when I say pairs, I mean one of them is a complex conjugate of the other one. So this one, when we simplify this and raise it to the power 1/3, what we are going to get is going to be a complex conjugate of this, right? Because that is how the complex solutions occur. Guys, for that matter, even the solutions with radicals also occur in the same way. They occur as conjugates of each other, and same thing with the complex solutions. They occur as conjugate pairs. If -1/2 plus I radical 3/2 is one of the values or solutions of an equation, then we are guaranteed that -1/2 minus I radical 3/2 would be the other solution. So we already know that, but now let us verify. We are actually going to take up this last value, raise it to the power 1/3, use the de Moivre's theorem, use the unit circle, and then see if we get the conjugate of that, okay? So let us go ahead and do that. I need some more space for that. So guys, what I'm going to do is I'm going to get rid of, let us get rid of this stuff right here, right now. Okay. So from here, what we can do is, got to take this up. So it is cosine of 720 plus I times sine of 720, and got to raise it to the power 1/3. So raising it to the power 1/3, again, we're going to use the de Moivre's theorem, which tells me that I just have to multiply the exponent with the angle. So it's going to be cosine of 720 times 1/3, which is going to be 240 degrees, plus I times same thing, sine of 240 degrees, right? Now I'll look into the unit circle and see what the values for cosine and sine are. Cosine, I have -1/2, and sine, I have minus radical 3/2. So guys, we already knew that it was going to be the complex conjugate of this one, and that is exactly what we get when we raise this third value raised to the power 1/3. So guys, let us verify. We are actually going to take this 1/3. So guys, these are the three solutions or three cube roots of unity, and we were guaranteed to have three of them. Guys, if it says four roots, then you have to find four of them. If it says fourth root, then you have to go one more time around the circle. So you will have to go 360 plus 360, which is 720, and then you have to add one more to it, and then we'll have four of those. Now guys, we have these three. Now let us try to make more sense out of them. One of the things that we want to clarify that, hey, why didn't we go beyond three? Why didn't we stop right here? And then we also want to see if there is anything that kind of stands out that is unique about these solutions. And guys, there is few things. So in order to do that, let me get rid of some stuff here so that we can actually analyze, or we can look at this from a visual perspective. So guys, I think I can get rid of all this so that I can show you how these things look on the circle or on the complex plane. So the three solutions that we got were, get rid of this. So the three solutions that we got were, I'm going to write them here. Guys, I got 1, then -1 plus I radical 3 over 2, and then there was -1/2 minus I radical 3 over 2. Guys, this one was, for this the angle was 0, for this the angle was 120 degrees, and for this the angle was 240 degrees. So now let us look at this. This is the complex plane. This is my real axis, this is my imaginary axis. My first solution was on angle 0. This was my first value or first solution. Let's say this is angle 0, right? This is my first value, which was just 1. Guys, my other second value was right here. And the angle that it made with the reference side was 120 degrees, and the value for that was for 120 degrees. Well, we got that, and then the value was 1/2 plus I radical 3 over 2. So this was my first complex number. Let us call it Z1. This was my Z2. This was the first cube root of unity. This was the second cube root of unity, and the third one was, guys, again, it was 120 degrees. It was 240 degrees from the reference side, but if from the other cube root of unity, it is going to be 120 degrees, because this total angle was 240. So I just had to subtract 120 to get this 120. And finally, if I have to measure the angle from this last one, this Z3, which was -1/2 minus I radical 3 over 2, guys, this angle is also going to be 120 degrees. So guys, we can see a pattern here that these three cube roots of unity are separated by an equal amount of angle, which in this case is 120 degrees. So guys, if I already know that the first one was 120 degrees from the reference side, then we can figure out the other one as well, just even by just adding 120 to this, and from here I would reach up to 240 from the reference side. From there I can see the value for the cosine and the sine. That is one way of looking at it. The other way is, we already know that if a complex number like this is a solution of this, or is one of the values of the cube root of unity, then the other one is going to be the conjugate of that, which is going to be the minus. You have to change the sign in front of the I. So guys, whether you like to think or remember that the complex solutions occur as conjugate pairs, and one should actually remember and know that. But then also visually we can see that these are separated by equal amount of angle. Now guys, if we go around one more time, like if you remember, we added 360 once and twice, so we went around twice around this circle, right? Well, this is a unit circle here, right? So guys, here, if I go around one more time, then I'm just going to overlap on this. So it is the same thing, 1. Again, if I try to go around one more time, I'm going to overlap with this guy. So it is still going to be this value. And same thing one more time. So if we keep on going around the circle, it is going to just overlap with one of these three values. So guys, keep in mind, we are only going to get 3 values. That's why we only add 360 twice, right? So that's how we basically find the cube root of unity. Guys, this is not only something that will work only for finding the Q root of unity. Now, this is the concept, or this is the method that will basically work for finding the roots for any particular complex number. Guys, it can be as simple as 1, or it can be as complicated as any other complex number which has a combination of real part and an imaginary part. And I want to show you a few more examples where we are going to figure out the roots, maybe fifth root or fourth root or square root of some other complex numbers. But guys, you will see that the process and the steps are going to be the same. Guys, in this case, this was like just finding 3 of them, and it was not too complicated to do that. And it's a very classical example. This is where everybody likes to start when they start talking about the roots of a complex number. So guys, try to understand this step by step. I think I was able to break it down into steps, and then I'm going to show you a few more examples. Till then, keep practicing. I will see you next time.